Hello, my name is Professor Edgar Chalmers. I'm a maths lecturer at the University of Wokingham. This is the third part of the lecture series, an academic lecture on every positive integer from 1 to 1 million, intended for A-level maths students of any exam board. And during this lecture, we will be looking at the number 3. Please note that this lecture assumes you have already watched the lectures 1 and 2 from the same series. So, first, an introduction to the number 3. This is the appearance of the number 3. It is very important that you do not confuse the symbol 3 with the symbol for the number 8. Many an A-level student has misinterpreted a 3 as an 8 or vice versa, and will have subsequently failed a question on their final exam. So it's important that you understand that if the left side is filled, it is an 8 and not a 3. We will be covering 8 in greater detail in the future lecture 8. These are some other ways you may see the number 3 represented. For example, its alphabetical form and its Roman numeral form, as we can see here on the right. If we look at 3's position on the number line, it is between the numbers 2 and 4, that is 1 after 2 and 1 before 4. 3 is, of course, one of the most common numbers in mathematics, and it is extremely important for success at A-level that you become very familiar with its usage. You must expect to see it frequently on your exam. And, of course, 3 is a positive integer. Here are some examples of the number 3 that you may have encountered in your daily life up to this point. For example, the number 3 bus. Perhaps you take a number 3 bus. Perhaps your birthday is on the 3rd of a month, which is, of course, represented with the number 3. Perhaps your house number is 3. My house number is 46. This is someone else's house number. Or you may see it in popular media. For example, the television channel BBC 3 or the film Toy Story 3. I know it's not obvious that that is Toy Story 3 unless you have an intense familiarity with the Toy Story franchise. Personally, I'm quite critical of this poster, for it does not feature the words toy or story. It entices one to believe that the film is simply called 3, but no, this is Toy Story 3. So an ineffective poster, in my opinion, but we should move on. However, it is important to note that you must also have a deeper understanding of what the number 3 represents. So I have included some examples of 3 things. For example, 3 peas in a pod, 3 fingers, or a common sight in a classroom might be 3 staplers, which is the standard required number for most classrooms. Similarly, we have trios in popular media, examples of 3 individuals: the 3 Musketeers, the 3 Little Pigs, the 3 French hens, and of course the Holy Trinity. So now let's look at formation of the number 3. The most common formation of the number 3 is 1 plus 1 plus 1 equals 3, which can of course also be represented as 3 times 1 equals 3. However, another common formation of the number 3 is, of course, the addition system. 2 plus 1 equals 3, which, of course, can be reversed and also written as 1 plus 2 equals 3. Now, there are, of course, also many subtraction methods, but they involve numbers larger than 3, which we will discuss later, so I'm not going to go into these too in depth. But, for example, 4 minus 1 equals 3 is an example of the subtraction method. There are multiplication methods. However, it is important to remember that 3 is a prime number and therefore has only 2 factors, which are 3 and 1. Therefore, there is effectively only a single multiplication method, which is 3 times 1 equals 3, which we have discussed above. And finally, division methods are also possible, but as with subtraction, largely rely on far larger numbers, so will be covered in future lectures. However, it is also important that you understand how to use and manipulate the number 3 in equations. So, for example, a common example would be 3 plus 3 equals 6. 6, of course, will be covered in a future lecture. 3 minus 1 equals 2 is an example of the subtraction method used with a 3. It is, of course, the same as 2 plus 1 equals 3, if you comprehend the relationship between addition and subtraction. The 3 is also used in multiplication methods. For example, the 3 times table extends into, again, far larger numbers, and will be further covered later. But as a starting point, it is important to remember that 6 and 9 are both numbers on the 3 times table. For example, they are 3 times 2 and 3 times 3, respectively. And division is also possible, but once again, you must remember the prime number status of the 3 has limited its factors. You may recall when we discussed 1 that each number divided by itself causes the number 1, and this is also true of 3 being one of the numbers. So 3 divided by 3 equals 1. However, there are also advanced techniques in your usage of the number 3. For example, we can see here 3 to the power of 3 is the large number of 27. This is similar to, as we discussed in the lecture 2, the 2 to the power of 2, which is of course 4. You may be asked to perform multiple operations at once. For example, 3 to the power of 3 divided by 3 plus 3. That may seem fairly daunting. However, you will soon come to appreciate and understand equations such as these. Be warned, 3 is a frequent component of equations, and you will often be expected to know how to use it in such an equation. Skillful manipulation of 3 is essential for a good grade at A-level, considering the frequency of the number in mathematics. I just would like to take a brief recess from the discussion of the number 3 to discuss triangles, which are, of course, a 3-sided geometric shape with 3 points. This lecture series is primarily about integers rather than geometry, but it is important that you recognize the triangle as a geometric symbol, or clearly related to the number 3. For example, here we see many different triangles. You may have seen some yourself, such as this road sign or this cheese-flavored potato snack. For further information on triangles, please see the lecture series, an academic lecture on every regular 2D polygon from the circle to the megagon by Professor Samantha Rigby of the University of Scunthorpe. A close colleague of mine, Professor Rigby, a very talented mathematician and also a talented windsurfer. So let's tackle a practice equation involving the number 3. I have a pen here. We can see the equation 3 plus 3 times 2 minus 1 times 3 minus 1. Now, a common way of tackling this equation is by using the Pobiol-Fuggen-Modas system, which is, of course, parentheses, brackets, exponents, orders, logarithmic functions, geometrics, golden numbers, multiplication, division, addition, subtraction, and supplementaries. So we can apply each of these to the equation above. Are there any parentheses? No. Are there any brackets? No. Are there any exponents? No. Are there any orders? No. Are there any logarithmic functions? No. Are there any geometrics? No. Are there any golden numbers? No. Is there any multiplication? Aha! Here we can see 2 examples of multiplication. These, of course, equal 6 and 3 respectively. If you're confused about why this one equals 6, please return to a previous slide and consider. Is there any division? No. Is there any addition? Aha! We can see an addition here, which means we must do 3 plus 6, which of course equals 9. That is 9. Is there any subtraction? Aha, two examples of the subtraction symbol in this equation. We must take the 9 we have already generated from the addition and the multiplication and subtract a 3. This, of course, receives the answer 6. And then we must subtract 1. It's important not to miss off this final step. 6 minus 1, of course, equals 5. So the answer you would give would be the number 5. I apologize for my poor handwriting. I am attempting to do this using my computer mouse. I'm far more skilled with a sensible pen. So I have included here some more practice questions involving the number 3. Feel free to stop the slide and tackle the questions in your own time. I am sure a competent teacher will be more than capable of supplying you with the answers. So 3 plus 3 plus 1. 3 divided by 3 plus 2. 3 minus 3. This is a surprisingly challenging question, so be careful with it. 3 times 3 minus 3 times 3 plus 3, also fairly fiendish, may be found towards the end of an exam paper. And finally, a particularly tough one, which you would almost certainly find as one of the last few questions on your exam paper, 3 to the power of 3 divided by 3 minus 3. As you can see, it is very important to understand the number 3, considering its frequency of appearance in questions such as these. So, in summary, what have we learned during this lecture? We have learned that 3 is a positive integer. We have learned that there are many ways to form the number 3. We have learned that 3 is commonly used in equations, including with advanced techniques such as 3 to the power of 3. We have learned that 3 is an expected skill at A level. And finally, we have learned that Professor Samantha Rigby is a talented windsurfer. That is the end of this lecture. The series is continued in the lecture 4, which will cover the number 4, 1 after 3. Feel free to stop the video and continue with that video now. I'm sure it will be available in the playlist I have created for all these numbers. However, if you would like more information on the number 3, perhaps more curious and inquisitive students may wish for a deeper exploration of the number 3, my accompanying books, An Essay on Every Integer Between 1 to 1000, and the rather more humorous book, Numbers, What on Earth Do They Mean?, both contain fascinating passages on the number 3, which I would highly recommend, even if I do say so myself. More intelligent students may enjoy the book 3, The Hidden Story of the Third Number by Professor Philip Watkins of the University of Dulwich. An acquaintance of mine who I've met on a few occasions, whose academic writings on numbers such as 3 are unparalleled in the academic world. And 3, The Hidden Story of the Third Number, is a much deeper exploration, a look at the fascinating history behind the number 3 and its role in everyday mathematical society. However, I must advise you to avoid the book Secrets of the 3 by Juliet Marsala. Miss Marsala is something of a pariah in the academic mathematical community, and the book Secrets of the 3, if I can be frank for a second, is useless pop science. It contains no hard facts. It's full of speculation and arbitrary meaning. It's certainly a book to be avoided for academic study, or even for personal pleasure. Thank you. That is the end of the lecture. You may now continue to 4, if you so wish.